Hi guys, it's Mr. Mustafa here. In this video we're going to solve the Mathematics Paper 2, June 2024, and it's the province of KwaZulu-Natal. So it's this paper here, which was basically 3 hours and 150 marks. So let's go straight into question 1. And let's solve the paper. Question 1. Let's take the diagram as well. Right, now in solving this question, let us read what's given here. In the diagram, DEFG is a parallelogram. So we have DEFG, that's a parallelogram. You know what's the properties of a parallelogram. Both pairs of opposite sides are parallel, diagonals bisect each other, common midpoints, both pairs of opposite sides are equal, both pairs of opposite angles are equal, and so on. With vertices D, E, F, G, so we have these 4 vertices on the parallelogram. GH is parallel to EF. Let's see if that information is given. GH is parallel to EF. Basically most of the information is given. H is on EF. EH equals HF. EH equals HF, so that makes H the midpoint. The angle of inclination DG is beta. Angle of inclination of the line DG is beta. DE has a positive gradient. Where's DE? DE has a positive gradient, of course, because you can see the line is upward sloping. DG cuts the y-axis at J, 0 and 5/3. So DG cuts the y-axis right there. The length of DE is 5√2. The length of DE is 5√2. The reason why they gave us this, the length, because we can use the distance formula and get the value of x, right? Now let's get into the question, because we understand the diagram. Make sure to read all the information, because sometimes the information is not marked on the diagram. Alright, so now question 1.1, we want to find the gradient of EF. The gradient of EF. Alright, it's quite simple, because we can use the gradient formula. You know what's the gradient formula? y2 minus y1 over x2 minus x1, right? And as we see, y2 minus y1 is, because we're doing EF, let's take F as a final point. So this will become, you know, x2, y2, and this will become x1, y1. So because I'm finding the gradient of EF, we're going to say y2 is minus 8 minus 0 divided by x2 is 1 minus 5. Minus minus becomes a plus 5. So what's our answer? Minus 8/6. If you put that in the calculator or simplify, divide by 2, you should get negative 4/3. And that's what we expected the gradient to be negative, because it is a downward sloping line. Then obviously if the gradient is negative, we can find the equation of the line. Anyways, let's see what's the next question. Calculate the coordinates of H. Right, in calculating the coordinates of H, how do we calculate the coordinates? Right, to find the coordinates of H, you can clearly see that EH is equal to HF, so that's the midpoint. You know what's the midpoint formula? Is x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So if we calculate this, we can see we add the 2x values, so minus 5 plus 1 divide 2, and we got 0 minus 8 divide 2. So we should get the midpoint to be, we got minus 4/2. Minus 5 plus 1 is minus 4, divided by 2 is minus 2. And 0 minus 8 is negative 4, divided by 2 is negative 4. So the coordinates of H we shouldn't put m here, we should put the coordinates of h. So what's the coordinates of h? Therefore h is -2 and -4. Right, so we can put that on the diagram, -2, -4. So remember the coordinates of h is given now. Next question. Determine the equation of GH. The equation of GH in the form y equals mx plus c. Now to find the equation of GH, we need to see what information we have so far. Right, so we have already calculated that the gradient of EF is -4/3, so obviously the gradient of GH will be 3/4. So you take the opposite sign and you flip this, or in other words, negative reciprocal. So what's the gradient of GH? Remember, you need to take the opposite sign of this because these lines are perpendicular. So opposite sign of this will be positive, and you invert this, so it becomes 3/4. So it becomes 3/4, and the point is clearly it occurs at h, right? At h -2 -4. Now I will use this equation of the line y minus y1 equals m into x minus x1, and then obviously we'll put it in that form. Where's x1 y1? Is there's x1, there's y1, because remember this was perpendicular, right? And there's h here. Because this is perpendicular and the gradient of this line is -4/3, then the gradient of this line we have, which is positive 3/4. Right, so now y minus y1 at this point h. So y minus y1 is -4 is +4 equals m, which is 3/4 into x plus 2. So what we have now is y equals, you can open this up and take the +4 over, it becomes -4. If you open this up, you get 3/4 x. 3/4 times 2, the 2 and the 4 cancels out, so you're going to have plus 3/2, because that is 6/4 is basically 3/2. So therefore we have y equals 3/4 x. So we have 1.5 minus 4, which is -2.5, give us -5/2. You can check this up on the calculator, right? You can just say 3/2. 3/2 minus 4. Right, so what we have, -5/2. So now remember, the -5/2 is the y-intercept, so we can put -5/2 here if you like. Right, we don't have to, because we don't want to make this diagram too messy when you put too much of information on it. Next one is calculate the size of beta. Right, to calculate the size of beta is an angle of inclination. So if you remember the formula clearly, or if you remember the inclination angle formula from the formula sheet, they tell you m equals tan theta. So, or let's write it as tan beta equals m. You'll find that m equals tan theta is one of the formula that's given on the formula sheet. Now obviously in our case we don't have theta, we want to find beta. Right, so now let me just recopy this diagram here in this problem to solve this. Right, right, so we have our diagram back here. Now remember, we want to find this inclination angle beta here. So to find the inclination angle beta over here, how are we going to solve this? We need a gradient of this line. Now remember, the gradient of this line is the same as the gradient of this line here. So we're going to say gradient of dg is equal to the gradient of EF. And what's the reason? And that will give you -4/3. I think it was -4/3. Was it -4/3? Yes, it's -4/3. Right, so now we have a gradient and then we got the inclination angle. Now why is the gradient like this? The reason why the gradient is like this, because the lines are parallel. So because dot dot dot, you can write reason DG is parallel to EF. I think we should write a reason here as well, don't just guess. Why we're writing the gradient of GH is 3/4 is because this line here, because EF is perpendicular to GH. EF perpendicular to GH. We should write a reason here. EF is perpendicular to GH. That's the reason why. So the examiner can see what you are writing. Okay, now we'll use this formula. So we got tan beta equals -4/3. So beta reference angle. You know how to solve trig equation. So what's the ref angle? Ref angle is tan inverse. Don't take -4/3, always take +4/3. Then we will use the cos diagram. So what's tan inverse 4/3? You're going to go shift tan 4/3. Tan inverse 4/3 we get is 53,13 degrees. So we got 53,13 degrees. But remember, tan is negative, and where is tan negative according to the cos diagram? Right, it's negative in the second and fourth quadrant. Obviously we're not going to take the fourth quadrant because we want an angle which is obtuse. So therefore beta is now equal to 180 minus 53,13 degrees. And what's 180 minus 53,13? Let's say 180 and minus the answer that was stored. So I'm getting 126,87, right? And that's my inclination angle beta. I hope you guys are understanding. Don't forget to leave comments if you don't understand. Right, moving on to the next question. Calculate the size of OJK. Remember guys what that big figure is. It's a parallelogram. So we want to find the size of OJK. O, J and K. Now what's OJK? What is this top angle here? Now remember this top angle here. What is the top angle? OJK. We know that this angle is 90. Why? Because it's the crossing over of the x and y axis. X axis is perpendicular to y axis, right? So we know that angle is 90. So we can just use exterior angle formula, right? So exterior angle beta. So what we can say is angle JOK plus angle OJK is equal to beta. And what's the reason why we're adding these two? Because that's exterior angles of triangle OJK. Right, now we know what the beta angle is. Beta angle is 126,87, right? And we know what do we want to find? OJK. So OJK. And JOK, we know that this is 90, right? So this implies OJK is equal to 126,87 minus 90. You should get 36,87 degrees. Let's just check that. 126.87 minus 90. So there we have 36,87 degrees. That's the size of OJK. Nice simple problem. Or you can go and find the angles on a straight line, then sum of angles of triangle. Right. So I hope you guys are understanding. Next one, calculate the value of x. Remember what we said, how to calculate the value of x. We mentioned that right at the beginning, that to calculate the value of x, we're going to use the distance formula, right, and then solve. So here's my diagram. Okay, let's put the diagram here and work accordingly. Right, so let's put it here. Okay, so now I have my diagram. I'm going to use the distance formula to solve this problem because we want to find the value of x. Where is x? X is right here. Okay, now you remember the distance formula. The distance formula is d equals the square root of you can say x1 minus x2 squared plus y1 minus y2 squared. You will find this on the formula sheet. Now remember, if I square both sides, what is d? D is the distance ED, right? Now if I square both sides, I can just write it down as like this: x1 minus x2 squared plus y1 minus y2 squared. Okay, let's just substitute everything inside and then square both. We know the distance is 5 root 2, which is equal to the square root of what? X minus minus 5. So x plus 5 squared plus 7. Remember, I took that first, so 7 minus 0. Now if I square both sides here, I will get 5 root 2. Okay, if I square both sides, I will get 25 times 2. Now remember, if you're squaring both sides, square this side and square this side. See what happens. If I square this side, it becomes 25 times 2, which is 50. And if I square this side, I will get x plus 5 all squared plus, I'm simplifying the inside, 7 minus 0 all squared is 49. The square and the square root falls out. Now don't get into the habit of opening up this whole thing, because remember, to solve this problem you can just take the 49 over. So 50 minus 49 is 1, and we got x plus 5 all squared. Now you know, when you have a square of a number is equal to another number, you can just take square root on both sides. So you can say x plus 5 is equal to plus minus the square root of 1. So remember, we are square rooting, so plus minus 1. So we have two answers. X is equal to minus 1 minus 5, or x is equal to plus 1 minus 5. So now we have x is equal to minus 6, or x is equal to negative 4. So which one you think is going to be? The value of x, which is negative 6, or the value of x, which is negative 4? So as you see here, this is already negative 5, and they said ED has a positive gradient. So the value of x can't be less than negative 5. It has to be more than negative 5. So the value of x equals to negative 4 works. So we're going to write reject here, right? Because since x needs to be greater than negative 5. Why are we rejecting? So we only have one answer. Therefore, this implies the answer for x is now equal to negative 4. I hope you guys are understanding. Right, let's move on to the next question. Area question. Calculate the area of DEOJ. Now, how are we going to calculate the area of DEOJ? Let's retake this diagram again. Right, so let's see how we can find the area of this DEOJ. DEOJ. Okay, so DEOJ is this part here. We know that this is 90. What's the problem here now? Okay, this is not even a parallelogram, as you see here. We have a slight problem. Okay, so it's a quadrilateral, general quadrilateral. But if you're looking at this, triangle here, look at this triangle. If you take this entire big triangle, right, we have a perpendicular height, right, which is 7. Look at the y value, it is 7, perpendicular height. We know the distance from E to K, which means that we need the coordinates of K. Can we find the coordinates of K? Yes, we can, because that's the that's the x-intercept of the line DJ. So let's find the why do we need the coordinates of K? Because once I have the coordinates of K, then I can find the area of the small triangle and subtract. So what I'm going to take is the area of the yellow triangle minus the area of the green triangle. I'm going to minus this part here, so you will be left with this part. So let's find the coordinates of K. Alright, so we're trying to find K. So what's the equation of line DG? To find the equation of line DG, g or dk. We know x value is -4, so I'm using the answer from above, which is -4. Now what if we didn't have the correct x value above? How would we solve it? Then we have an issue, we have a problem in solving that problem there. How will we solve that then? We have an inclination angle here. Inclination angle, we can find another inclination angle here. Can we use the, we need the value of x there. Alright, so anyways, let's find the equation of dg. So what's the gradient? We know the gradient of dg is, that's easy, because gradient of dg is already, I think it was -4/3. Let's just check that up. It's the same as the gradient of EF. We did find the gradient of dg. It's -4/3, right? So it was -4/3. Gradient of dg is -4/3. We even have a y-intercept, which is 5/3. So y equals mx plus c plus 5/3. We're going to find the coordinates of k, so we're going to make y 0. So -4/3x plus 5/3. You can multiply the entire equation by 3. So you got 0 equals -4x plus 5. You take the 5 over and divide it by 4. So x equals -5 over -4, which is, or keep the 5, take the 4x over and divide by 4. So 5/4. So now we know what the coordinates of k is, right? So k is 5/4 and 0. So let's put 5/4 here. The value is 5/4 over here. So we know the distance from -5. Remember, 5/4 is the same thing as saying 1.25, right? 5/4 is the same thing as saying 1.25. So let's just say 1.25 instead of 5/4. 1.25. Now we can find the area of triangle DEK. Area of triangle DEK, which is half base times perpendicular height. So it's half. What's the base? The base is the distance from here to there is 5 plus 1.25. So I'm going to say 5 plus 1.25 times 7. Let's see what area we get. So what we got, half into 5 plus 1.25 is 6.25, right? And then I'm going to times it by 7. I will get 21,875. 21,875 units squared. But now we're not done, because we need the area of the small triangle here. That's easy, because half base times height. And then got area of triangle JOK. Alright, that's half base times perpendicular height. That's half. What's the base? The base is just OK, which is 1.25, and the perpendicular height is 5/3. So let's multiply that out now. Half times what we're saying is 1.25 times 5/3, right? Let's check this out. Times 5/3. Let's delete that 5/3, and I'm getting an answer of 1.042. 1.042. So now we can subtract these two areas, because we need to remove this green triangle here. So if I subtract the area, then you say area of triangle, area of quadrilateral, not triangle, area of quad, DEOJ, right, is 21.875. 21.875 minus 1.042. I am getting 20.833. 20.83 units squared. Yes, I took 3 decimals here, I took 3 decimals here, and final answer 2 decimals. So just keep your rounding to 2 decimal places in the final answer. In between, try to take more decimals because you want to be as accurate as possible. Moving on to question 2. As we see here, we see that we have an equation of a circle. And question 1 and question... Alright, let's do the first 2 questions together. Moving on to question 2. Right, so let's see what information is given. Make sure everything, you read everything and mark the diagram. In the diagram below, P is 3 minus 2. 3 and minus 2 is a point here. Is the center of the circle that has the y-axis as a tangent. A and B are the x-intercepts of the circle P. Now what you should be doing is, when they tell you that, draw a line from here to there. Right, so if you draw this line, we know that the distance from here to there, okay, we don't know that distance, but we know what the x value there is, 3, and going here, so it's the same value here, 3, and thus minus 2. So clearly we can see that the distance from here to there, right, and we don't know what that distance is. Alright, actually we do know what this distance is. That's also minus 2, so that should be 2, and the distance from there to there, so basically the radius here is 3. So we know the radius is 3. Perfect, that's good. So determine the radius of the circle is the distance from here there. So radius is equal to 3. The equation of the circle, so to find the equation of the circle, we can just write it in center radius form. Okay, equation of the circle, what is center radius form? X minus k all squared plus ln k. Okay, so remember we need to minus the 3 plus y minus minus 2 will become y plus 2 all squared is equal to r squared, which is 3 squared. In other words, we have x minus 3 all squared plus y plus 2 all squared is equal to 9. So center radius form. So this is CR form. I don't think you need to write it in standard form because it's just 1 mark. If they gave us more mark, they should have classified here. Anyways, continuing on to the next question. Calculate the distance AB. To calculate the distance AB, how can we calculate the distance AB? Yes, how can we calculate the distance AB? Let's take the circle here. Right, so remember we have the equation of the circle already. Since we have the equation of the circle, we can calculate the distance AB. And how so? We can calculate the distance AB because, yeah, A and B are the x-intercepts, right? Or we can calculate the distance AB like this, right? So remember, from here to there, what if we draw a radii? Now let's just take the x-intercepts of the, and these are the x-intercepts, so you make y 0. So we have x minus 3 all squared plus 0 plus 2 all squared is equal to 9. And now remember this is 4, we're going to take the 4 over, so we'll get 5. 9 minus 2 squared, which is 5. And this is x minus 3 all squared. Now you know how to solve this equation. X minus 3 is equal to plus minus the square root of 5. So x is equal to negative root 5, negative 3, positive 3 because we're taking the or x equals positive root 5, positive 3, positive root 5, positive 3. So if I want the distance AB, take that value minus this value. So distance AB is equal to root 5 plus 3 minus negative root 5 plus 3. So what we notice is that we're getting root 5 plus 3 plus root 5 minus 3. Plus 3 minus 3 cancel out. Square root of 5 plus root 5 is 2 root 5. Or you can write the answer in decimal form, 2 root 5. We get it as 4,47. 4,47 units, right? The distance AB, right? Perfect. 4,47 or 2 root 5. Moving on to the next question. So we have another circle that has equation x, right? Determine the radius and the coordinates of the center. So find the center and the radius. Now very important is, see how I work this out. I will write down x squared plus 2x, right, plus something squared plus y squared minus 8y plus something squared is equal to, take this 8 over and say plus something squared plus something squared. Now what is the something squared? Is basically the coefficient of x divided by 2. So 2 divided by 2. Coefficient of y is minus 8 divided by 2. So we put this, whatever we put here, we put the same thing here. 2 divided by 2 and minus 8 divided by 2. So automatically this one here will become perfect square. And how? We put an x here. What's the value of 2 over 2? Put inside here, that's plus 1. Automatically this one here, these three terms, what's the value of minus 8 over 2? Minus 4, right? And that, what are you adding here? 8 plus 1 plus 16. 9 plus 16, which is 25, right? So what's the center? The center is minus 1 and 4, and the radius is equal to the square root of 25, which is 5. I hope you guys understood that. So that was basically completing the square. Next question. Will the two circles intersect? So let's take this as we don't know whether the two circles will intersect or not. We need some calculations. So what's the thing about intersecting circles is that, remember, we don't know what's the theory behind intersecting circles. Intersecting circles is, you see, that's intersecting circle. So this is radius 1. We want to look at the intersecting circle, right? That's radius 1, and that is center A. And remember, this is, that is center B, and this is radius 2. So we're going to take the distance between the centers and the sum of the radius. So if the radius, in other words, if the distance between the centers, if AB is greater than or less than, if AB is less than R1 plus R2, then it will intersect. And if AB is greater than R1 plus R2, then they will not intersect. And if they are equal, then they will just touch. Alright, they touch externally. Right, so that's the theory behind. So this will intersect, do not intersect. Right, I don't want to get into too much technicality of this. There's also R1 minus R2 and stuff that you put on this side, but it's fine. For now, we'll work with this. because remember what's the coordinate? Minus 1 and 4. So if I try to put minus 1 and 4 here, right? Now remember this is a bigger circle. Where's minus 1 and 4? Minus 1 and 4 and radius 5. Where's minus 1 and 4? Minus 1 and 4. Minus 1 and 4 will just be around there, right? No, minus 1 and 4. So x value is minus 1 and y value is 4, is somewhere around here. So it's basically higher up. That's where the center is, right? So that's B. Let's just call it A, right? That's minus 1 and 4, and the radius here is 5. So that's the center of the circle. So we want to check if they're going to touch. Let's see, let's take the sum of the radius. So you can say R1 plus R2 is sum of radius, right? That's equal to what's R1 and R2? R1 was, what was the radius here? 3, and the second radius is 5. So you can say 3 plus 5, which is equal to 8. That's sum of radii sum, right? Now what's the distance between the centers? Distance between centers, right? What's the distance between the centers? The distance between the centers is using the distance formula. Original point was P, 3 and minus 2, and the second point here is C. The center was minus 1 and 4 of the new circle. So if I take the distance formula, remember x1 minus x2, we did it in question 1. So 3 plus 1, 3 minus minus 1 is plus 1 squared, plus minus 2 minus 4 squared. So what I'm getting here is the square root of 16 plus 36, which is the square root of 52, right? So 36 plus 16, square root of 36 plus 16, or you can just work the entire thing out on the calculator. You're getting 2 root 13, which is 7,21. So what's the answer? The answer is 7,21. So we can clearly see that the distance is less than R1 plus R2. This implies will the two circles intersect? The two circles intersect. Okay, so the two circles do intersect. Moving on to the next question. Right, so this is a transformation question, which is saying that the circle with center P is reflected about the line y equals -1, right? Write down the equations of the horizontal tangents to the new circle formed through this reflection. So we want to reflect this, right? Let's copy this. Now remember, you are reflecting a point, right, and the entire circle. So you're reflecting about the line y equals 1. So remember, minus 2 is down, so 1 is somewhere around here. I'm just taking symmetrical, right? This is y equals 1. So where will the center be? See, remember the distance from here, so that's y equals 1. That's a line of reflection, right? We can clearly see that the distance from here to there, right? So from the point to the line, the distance from the point to the line is 1. Why? Because from minus 2 to minus 1, right? That's minus 1. And the distance from here to there will be 1 as well, right? So basically this point gets reflected there. Now because what's the point after what's the circle after the reflection? You're reflecting about this line, so this point goes there, right? So that is 0, right? At the moment the horizontal tangent here is, remember the radius was 3, and that's another 1. So at the moment the horizontal tangent is y is equal to 3, and the second horizontal tangent is y is equal to, coming down, y is equal to -5. So your horizontal tangents are between y equals 3 and y equals -5. Sorry, y equals 1 at the moment. No, not 3. 1, 2, 3. So y equals, yeah, it's from here to there. The original is y equals 1 and y equals -5. Now, after the reflection, what happens now? Your point P1 is here, so you need to go 3 up. Why 3 up? Because the radius is 3. It's the same circle you're reflecting. So if you go 3 up, your circle will be somewhere around here. Okay, so let me just trace this out for you and then show you that where will the circle be. So I'm just going to trace this circle. Right, now see, your circle will be here now, because that's my center. I'm reflecting it about the line. My center is somewhere around here. Yes, see, so that's my center. Right, now best thing to do is go 3 up. Wait, let's undo this. Right, so we're basically going another 2 up here. If you go another 2 up over here, you're getting y equals, because you need to go 3 to the radius. Where's the radius? The radius is from here to there, which is r equals 3, and the radius is from there to there, r equals 3. So now your equation will be y equals 3. Horizontal tangents will be at y is equal to 3 or y is equal to -3. Very good question. Right, moving on to the next question, which is question number 3. We move on to trigonometry. Right, taking question 3.1, 3.1.1. In the diagram below, P is a point in the first quadrant such that 5 cos theta equals 3. Now, whenever they give you this, make cos theta. What are you going to say? Cos theta is equal to 3 over 5. Right, and R is K and 6. R is K and 6. This theta here, in the diagram below, P is a point in the first quadrant such that 5 cos theta equals 3 over 5. R is 6 and K is a point in the second quadrant such that POR is 90. So remember, OP is perpendicular to OR, that is 90. Right, so how are we going to solve that? Remember, this angle here is 90 minus theta, because this is, we only left with angles on a straight line. Okay, so that's 90 minus theta. Remember, this angle here is 90 minus theta. We're trying to understand the diagram. Right, so now let's solve this. What is tan theta? So tan theta, remember, I'm going to drop down in perpendicular. What's adjacent? Adjacent is 3, the hypotenuse is 5, so the opposite will be 4. Right, so that's by Pythagoras. So we can just write down how are we going to show this. We're going to show this by saying y value. Right, that's y equals 4. So you're going to say y is equal to 4. So how you solve this? You're going to say y is equal to square root of 5 squared minus 3 squared, and that's because of Pythagoras. Right, and y is equal to 4. Why are we saying the positive value? Because is that one. So tan theta is in the first quadrant. Tan theta is opposite of adjacent, so 4 over 3. I hope you guys are understanding. Right, so simple cast diagram problems. Moving on to next one. What is sine 2 theta? What is sine 2 theta? Sine 2 theta is, yes, you have to remember that's a double angle, so you need to expand that. So that's 2 sine theta cos theta. 2, what is sine theta? From the diagram, sine is opposite of hypotenuse, 4 over 5. And cos theta is 3 over 5. So you can see if you multiply everything out, you're going to get 25 in the denominator. That's 12 times 2, which is 24 over 25. I just use a calculator to multiply that out as well. Moving on to 3.1.3, the value of k, and it's 5 marks. Wow. Alright, so let's see. Amazing. Right, let's see. Yeah, these are the types of questions that where you got to think. Now let's see, let me recopy this diagram down, right, and see what we can do here. The value of k, right? So remember, we forgot to draw this diagram as well. We need to drop down a perpendicular here, right? The distance from there to there is k, the distance from there to there is 6. This here we already have 3, 4, 5. Now this one, what's the problem here? Remember, we said that this angle over here, right, that angle over there will be 90 minus theta. So now how can we call this angle now? Alright, so obviously on your diagram sheet, make it angle O1. So we're going to write angle O1 is equal to 180 minus 90 minus theta. That's angles on straight line. Right, so we got angle O1 to be 90 minus theta. Let's fill it in. So angle O1 is 90 degrees minus theta. So what is this top angle here? I call it angle R1. So angle R1 will now become theta, because obviously if this is theta, the top angle is 90 minus, so that will become theta. R1 is theta. Why? Because sum of angles of triangle, which triangle? Let's just call it A, RAO, RAO, right, RAO. Anyways, you are allowed to relabel your diagram. Now, because we got theta angle on top, we got a perpendicular down here, we can find tan theta here, right? So now, tan theta from the big triangle, RAO. So that's k over 6, alright? But we also had tan theta before from the small triangle here. So we managed to take theta from the small triangle to the big triangle. So we know tan theta here is 4 over 3, right? And now clearly we can equate these two. So this implies k over 6 equals 4 over 3. You can just see how you're multiplying it out. So 3 times 2, right? You can see from here to there is times 2. So from there to there is going to be times 2. So you can just write down your final answer. K is equal to 8. Or you can solve the equation like this. Cross multiply. 3k equals 4 times 6, which is 24. So k is equal to 24 divided by 3, which is 8. So the value of k is 8. Nice question. Because these two triangles are kind of similar. Next question here, 4 marks. Right, we want to go and simplify the product of all these numbers. So what is this? Cos 385. Alright, so what we have here is, obviously we need to use reduction first. This angle is clearly more than 360. Alright, so we're going to simplify this. So this is here is equal to cos. Take away 360 from here. You're allowed to take revolutions from this. So if I take away 360, 385 minus 360, see what we get? 25. So we got cos 25 degrees plus beta, sine 35 degrees minus beta, plus cos 25 plus beta sine 35 minus beta, plus sine 25 plus beta times sine 55 degrees plus beta. 25 and 55. We can change this yeah, we can change the sine here into a cos. So we can keep it as sine, because remember what we want. We want 35 minus beta. So let's change the sine into a cos. So we're going to say sine of 90 minus 55 plus beta. Right. So now what we have, we got, so remember, I think you're going to be start with sine, end with sine. So that's going to end with sine. So let's say let's write this out first. I think it's a sine angle. So let's write out this first. So that is sine of 35 minus beta. 90 minus 55 degrees plus beta. Cos 90 minus 55 plus beta. No, we can't. It shouldn't be 90. It should be cos. Put a cos here. Yes, because cos of 90 minus is sine, right? So remember this, cos of 90 minus angle is equal to sine of the angle. So this is the entire angle I'm taking. So that's what I'm applying here. So let's write sine of 35 degrees minus beta cos 25 degrees plus beta plus cos 90 minus 55 is, should get 35, cos 35 minus beta. Why? Because 90 minus 55 and then negative beta, sine 25 plus beta. So remember, basically I'm starting with sine, ending with sine. So let's just say 90 minus 55. We can see we're getting 35. So our answer is correct. So now what is sine, cos, sine? That's the expansion for sine a plus b. So y plus, because there's a plus here. So what's the first angle? The first angle is 35 degrees minus beta plus cos the second angle. Remember, this is the first angle. This is like your A and that's like your B. So 35 degrees minus beta plus 25 degrees plus beta. What we can see clearly is that minus beta and the plus beta cancel. Remember, this plus here came from that plus there, from the plus above. Now that's the expansion for sine, cos, sine, right? So we got sine 35 plus 25, we have sine 60, right? And we know sine 60 is root 3 over 2, because if I use the triangle 30-60 triangle, we know sine 30 is half, so this is square root of 3. So sine 60 will be opposite over hypotenuse 60, right? So root 3 over 2. That's a special angle, right? Next one, or you can just use a calculator and type sine 60. Right, nice question. Let's look at this one. Prove the identity. Sine 3 theta is 4 sine theta cos square theta minus sine theta. Let's see. Sine 3 theta is left hand side, which is equal to sine 3 theta. We're going to write it as sine 2 theta plus theta. So the expansion for this is sine cos sine. So sine 2 theta cos theta plus cos 2 theta sine theta, right? Now what do we need to keep? We need to put everything in terms of sine and cos. So we're going to expand this out. So this is 2 sine theta cos theta times the cos theta plus cos 2 theta in terms of, do we write in terms of sine or do we write in terms of cos? Okay, let's write this in terms of, because we have 4 sine theta cos square theta here. That's a problem now. Which one should you write? Because over here you're going to get, just hold on with this, because there's 3 identities for cos double angle. So we're going to figure out which one to put there. I'll show you how to figure it out. Now, so we're going to expand this one now. This is 2 sine theta cos squared theta, right? So I need another cos squared here. Right, so we're going to say 2 cos squared theta minus 1. Use that one because uh, there's three basically expansion for cos double angle. There's 3 identities for cos double angle. So use this one because I want 4 sine theta cos squared theta. Now if you expand this, you're going to get 2 sine theta cos squared theta minus sine theta, and there you have the same terms, like terms. So 2 sine theta cos squared theta plus 2 is 4 sine theta cos squared theta minus sine theta, which is equal to right hand side. I hope you guys understood that. Excellent. RHS, not bad. It's just that this one here was a thinking one. The rest of them was simple. So always you break up the triple angle into double angle plus another single angle. Always do that. Next question. Hence or otherwise prove the following identity: sine 3 theta plus sine theta. So what we're going to do is we're going to say left hand side is equal to, we're going to replace sine 3 theta with 4 sine theta cos square theta minus sine theta. Remember, I only replace the sine 3 theta here, and then plus sine theta remains the same, divided by 2 plus 2 cos square 2 plus 2 cos 2 plus 2 cos 2 theta. I'm going to take out 2 as a common factor. I'm left with 1 plus cos 2 theta. And remember, this one cancels out with this one. Those two cancels out. Now we got a problem here because we got cos 2 theta here. So which one should you expand in terms of? Expand in terms of the one that will cancel out the one, right? Cos 2 theta is equal to 2 cos square theta minus 1. So I'll expand in terms of the first one. It's also equal to 1 minus 2 sine square theta. It's also equal to cos square theta minus sine square theta. So these are the 3 double angles for cos. So I'm going to expand this cos 2 theta in terms of 2 cos square theta minus 1. So I've got 4 sine theta cos square theta over what? Over 2 into 1 plus 2 cos square theta minus 1. Now you can clearly see the 1 and the minus 1 cancels out, and you're left with 2 times 2, which is 4. So you got 4 sine theta cos square theta divided by 4 cos square theta. Now what happens? Cos squared cancels out. So now you are left with sine theta, which is equal to RHS. So you prove the identity. I hope you guys are understanding. Let me put this in blocks because there's ideas. That's from your direct formula. This here comes from your formula sheet, alright? You gotta remember those. So that's the only one that you have to think about, you know, the cos double angle. The sine double angle is just straightforward, just one of them. So that's quite simple. Right, moving on to the next question. Determine for which values of, right? Determine all the values of theta for which the identity 3.3.2 will be undefined. So when will it be undefined? When the denominator is 0. When you divide by 0, then it is undefined. When d equals 0, denominator equal to 0, then you get undefined. So when will you get undefined? When 2 plus 2 cos 2 theta, 2 plus 2 cos 2 theta is equal to 0. So now I'm going to take the 2 over and divide it by 2. So I will get cos 2 theta equals negative 1. Now if you think about the cos graph, right, when it hits negative 1, it hits negative 1 at, when does it hit negative 1, right? So this is a cos graph. So it hits the negative 1 at 180 degrees, right? And at minimum and maximum there's just one solution, right? So no need to do two solutions. So we want negative 1. Negative 1 is here, and this is a cos theta graph. So you're going to say 2 theta, that's your reference angle, which is equal to 180 plus K360. Okay, 180 plus K360. Or you can use the reference angle story. Let's use, no, it's fine, because we know at 180 it is, that's 90, 180, 270, and that's 360, right? So we know that this is 180 degrees plus K360. Don't forget to write K is an element of integers. This implies theta is now equal to 90 degrees plus K 180. Right, I hope you guys understand. That's my general solution. So for which values of theta will this be undefined? Let's check if our answers are correct. If I put K as, just checking if we did this correctly, 2 theta is 180 plus K360, 180 plus K360, 90 degrees, we divided by 2, 90 degrees plus K180. Right, so if I put K value as 0, you will get theta as 90. Now theta as 90, substitute here. So cos 2 times 90, cos 180 is negative 1, negative 2 plus 2, that will give me 0. Don't substitute here now because this is a cos theta graph. I was just using that to find the 180. Okay, I use the graph to find where the value is minimum, at which x value is going to give me a value of -1. So I found 180. Right, so if you don't like working it out like this, or you can use the second method, like normal trig equations. -1, you can say ref angle. Reference angle is cos inverse 1, not -1. Cos inverse 1 will give me 180. And now you can ask yourself the question, where is cos negative? Cos is negative in the second and third quadrant, and you can see it's like on the line 180 minus 0. 1 cos inverse 1, sorry, you're going to get 0, not 180. Why am I writing this? You will get 0 degrees because cos inverse 1 is 0. Let's check. Shift cos 1. Yeah, the answer is 0. So you're going to get 180 minus 0 or 180 plus 0. So you get quadrant 2. Just do quadrant 2 solution. So if I do quadrant 2 solution, I'm going to get 2 theta equals 180 minus 0 degrees plus K360. So what you got? This implies theta equals 90 plus K180. So you get the same answer where K is an element of integers. I hope you guys understand this. I did it in two ways, graphical method and solving like this. I think you'll be more comfortable using the second method, the OR method, right? And the last one in trigonometry, determine the maximum minimum value of. Now they ask a lot of these types of questions, you know, in NBTs, where I did a lecture video on NBTs as well. So let's see, they ask questions like these. So we know the maximum value, max of cos 3x. The maximum value of cos 3x, remember the amplitude is a number in the front. So the maximum value of cos 3x is 1. Alright? No, actually we want the minimum value. So we know the minimum, not the maximum, min value. Read the question carefully. So the minimum value is 1 and minus 1. So the cos graph oscillates between 1 and minus 1. So we know the minimum value is negative 1. So what's the minimum value of cos 3x minus 1? Cos 3x minus 5. Now remember, it was minus 1, the graph shifted 5 units further down. So it's going to be minus 1 minus 5, which is going to be, because the entire graph shifts 5 units down. So the minimum value of this function is minus 6. I hope you guys understand. Right. Now, similarly, if you want the max value, of this entire thing here, this is an additional question. If you want the max value, it's going to be 1 minus 5, because the max value of this function is 1 and you're still moving 5 units down, so the max value here will be minus 4. Right, so that's not part of the question, we only wanted the minimum value. Right, this one here you can take it as an additional question. Right, so that concludes our trigonometry. Moving on to the next question, which is solution of triangles. So let's see what they're trying to do here. Question 4. It looks like a paper from, past papers. Not so bad. In the diagram below, RT represents the height of a vertical tower. So RT is the height of the vertical tower, with T as the foot of the tower. A and B are 2 points equidistant from T. A and B are 2 points, and these are the 2 points equidistant from T. It means they are equal. See how they phrase this, equidistant from T. You see, the phrasing is important. So we know that AT must be equal to BT. That's what it means. AB equals BT. Very important. Which lie in the same horizontal plane as T. So see, this is the horizontal plane. The height of the tower is H. The angle of depression of B from R. Now when you have angle of depression of B from R is alpha. The B from R is alpha. B from R. So looking down, you can take an alternate. Remember, this is parallel to this. So always take the angle of depression as an alternate angles and make it angle of elevation. And RBA is equal to beta. RBA. So looking at the front face. Remember, this alpha is for the side view. So we have one side, we have another side, and we got the horizontal plane and we got the front view, RBA. Right, so we understand the diagram. Now we can solve. So this is side 1, that's side 2, and that's the corner of the wall. These are the side walls. Determine ARB in terms of beta. ARB in terms of beta. ARB in terms of beta. Are we missing anything here? It's just one mark, ARB in terms of beta. Okay, so we can see that this is there. So how do we know that? Okay, so we have the same height here. We got this. So obviously this hypotenuse will be the same as well. Right? Why? Because BT and AT are equal. So RT is common height. Right? So these two triangles are identical, S1 and S2, right? So RAT is identical to RTB. So if this entire angle is beta, right, in the front view, this is also beta. So we're going to say RAB. RAB, I'm writing full reason, right? RAB is equal to RBA. RAB is equal to RBA. which is equal to beta. And what's the reason for that? Because these two triangles are similar, because uh, uh, not only similar, they're also congruent. So you can say, why we saying it's congruent? Because side angle side, side angle side, because RAT, triangle RAT is congruent to triangle RAT, we said. Why did I use RAT? Let's use RTA, triangle RTA, sorry. I'm not assuming anything, alright? So that's the reason I'm writing all these full reasons, even though it's 1 mark. Well, I know the answer. The answer is like, because we got beta here, that's 180 minus 2 beta, sum of angles of triangle. So what we have is trying to write reasons. So RTA is congruent to triangle RTB, and that was because of side angle side. Anyways, why side angle side? Because AT equals BT, that's given. RH is a common height, and those two angles are 90, 90. So side angle side. And this implies ARB is now equal to 180 minus 2 beta. That is sum of angles of triangle. Sum of angles of triangle R, sum of angles of triangle R AB, ARB, sorry, ARB. Sum of triangles of ARB. Well, we got the answer 180 minus 2 beta. Right, perfect. Let's continue solving. Now we can fly through this. 4.2. They said must prove that AB, in other words, prove that AB is equal to all of that, right? And we're going to write down, let me retake this triangle, because we made too many markings on the previous one. So let's retake this triangle here, right? Now remember what we want. We want AB. We know that this is alpha. We want to find AB, the distance AB. Okay, that's what we want to find. We want to find what is AB. Right, so we will start with the side triangle here. Remember, this was alpha, and we will find what is RB. So we can transfer RB and RA across, RA and RB. So you're going to say alpha is here. So what is RB? We can use H and alpha, right? H and alpha to solve. So and we want, so we're going to say we want RB, so that's the opposite hypotenuse, so we're going to say sine alpha is equal to opposite, which is H over RB. So this implies RB is now equal to H over sine alpha. Okay, H over sine alpha. So this is H over sine alpha, and we said this is also H over sine alpha, right? Because remember, this is beta as well. Now if you're looking at the front view, and we know that this is 180 minus 2 beta, right? So we can use the sine rule. So we can say, okay, we don't even need this side, okay? So we can just use the sine rule because we got 3 angles and we got a side, right? So we can say sine, we can say AB over sine R. So we can say AB over sine 180 minus AB over sine 180 minus 2 beta is equal to See this one here. RB, h over sine alpha over sine beta. Right, now we're going to cross multiply and solve everything. So sine beta times AB is AB sine beta, and h times sine 180 minus 2 beta. So h times sine, I'm cross multiplying, alright, so that times that, and this here times that. Sine of 180 minus 2 beta. That was h over something. It was h over sine alpha. Don't forget the sine alpha here. Right, now we're going to change this. We're going to change this here. So you have AB is now equal to h. We're going to divide by sine beta as well. So we're going to have, in the denominator, we're going to have sine alpha, and we're going to have sine beta. And on the numerator, we're going to have 180 minus the angle. It's the second quadrant, okay? That's in quadrant 2. Sine is positive, so that's sine 2 beta. And 2 beta itself is a double angle, so h times 2 sine beta cos beta divided by sine alpha sine beta. Alright, so remember we substituted here, and now we're going to cancel. We're going to cancel the sine beta and the sine beta. So what are we left with? Therefore, AB is now equal to 2 times h, which is 2h cos beta over sine alpha. And is that what we want? Right, so wasn't so bad. 2h cos beta over sine alpha. Right, perfect. Last one. This question in trigonometry. Question 4.3. Calculate the height of the tower rounded off to the nearest unit if AB is 5,4. If AB is 5,4, alpha is 51, beta is 65. So we want to find h, right? So let's say to find h, we're going to cross multiply again. We're going to say AB sine alpha, right? AB sine alpha equals 2h cos beta. So we want to solve for h, right? So h is equal to AB sine alpha over 2 cos beta. Now we can substitute all the information that's given, AB, alpha, and beta. What's AB? 5,4. Sine, what's alpha? 51. Divided by beta, which is 65. So 2 cos 65. And we're going to get what they said, to the nearest unit. Calculate the height of the tower rounded off to the nearest unit. Alright, so we're going to do that. Let's put this into the calculator. 5.4 sine 51 over 2 cos 65. What's the answer? 4,96. 4,96 units. So that's approximately equal to 5 units. Right, 5 units. Now see, we had that original question there. You can type it into the calculator and get the same answer, 4.96. Let me show you how to solve this trick. What's AB? 5.4 alpha equals, put a fraction there, 2, put your unknown as x, you're solving for h, so alpha x, open bracket, cos beta, so cos was beta, 65, close bracket, and divided by sine alpha. So sine, what is alpha? 51, right? Close and press shift, calculate or solve. So solve for x, see we're getting 4.96, right? So you can type the entire equation as is and solve for equations as well in this calculator. Right, so I hope you guys understand. Now we'll move on to the next question, question number 3. Not question number 3, what's the next question? The next question is question number 5. This is dealing with trig graphs. Taking question 5. In order to solve the value of a, we need to check that, let's see, value of a. Alright, so in the diagram, graph of g is a sine x. Right, that's a graph of g, which is a sine x, is drawn from minus 180 to 180. We can see this is the normal sine graph, and let's see, these intervals goes as half, -1, -3/2, -2. So we can see the amplitude is 2, so the value of a should be equal to, a is equal to 2. So let's write down the value of a. Value of a is equal to 2. Right, so a is 2. Look at the next question. We need to sketch this graph in the same answer sheet here. So what do we have? On the grid provided in the answer booklet, draw the graph of 2 cos x minus 30 for -180 to 180. Clearly indicate all asymptotes with the axes as well as the turning points and the endpoints of the graph. So what intervals can we choose? We can see that they gave us, I think, 1, 2, 3, 4, 5, 6. They gave us 30-degree intervals. So let's use the 30-degree interval and sketch the graph on the same system of axes. Right, so in order to sketch the graph on the same system of axes, we just have to go 1 x minus 30 degrees. Where's the answer booklet? They give us the graphs in the answer booklet. Oh, this paper doesn't have it. Okay, so we're just going to draw it on that. Show you how to use a calculator to solve this. Right, if you don't have the silver calculator, then you have to work it out for each. Right, so now we're going to draw the graph of 2 cos x minus 30. So you go to mode, table, let's call it f of x, 2 cos alpha x minus 30 degrees. Start at -180, right, end at 180, and step 30 degrees. Alright, right, so at -180 is -1,732. It's -1,732. 1,732 will be down here. At -150 is -2. -150 is -2. At -120 is -1,732. At negative, let's go back, calculator, -120 will give me -1,732. That's done. -90 will give me -1. So we know that's -90. At -60 is 0. At -30 is 1. 1 is here. At 0 it is 1,732, so somewhere around here. At 30 degrees it is 2, and Obviously at 60 is going to be 1,732 symmetrical. At 90 is going to be 1. That's 90 degrees. At 120 is going to be 0. At 150 is going to be -1. And at -180, -1,732 again. Right? So we're going to sketch this graph. Let's try to get a nice sketch. I'll sketch it in my highlighter, right? Okay, let's sketch it in the green. Right. But obviously you're going to sketch it much better because yeah, okay. So just this point here, let me try to smoothen this out. Trying to get this point right. That's 2 there, right? And yeah, it should be fine. Just sorry about this point here. Now let's look at the next question. That's my graph of f. Let's see what they said. Clearly indicating all intercepts with the axis as well as the turning points. So the turning point is there. It says 30 degrees. There's another turning point at -150. Let's see. That's -60 x-intercepts. That's 120 degrees, 150, 180. Right. We should be fine. Moving on to the next question. Write down the range of f. We can do both. Right. The range of f. The range of f you can clearly see is between -2 and 2. Don't forget to label this point -2 and 2. So y is an element from -2 to 2, or you can write it in interval notation, -2 less than equal to y less than equal to 2. The period of g of 3x. What is g of x? G of x is a sine x, so you need to replace the x with the 3x. G of 3x becomes a was 2 sine 3x. So to find the period, you have to take period of g of 3x is equal to 360 divided by k, which is the value next to the coefficient of x. So 120 degrees. The period of the general sine graph is 360, so 360 divided by 3, 120. Right, so far so good. Let's look at the next question. Determine algebraically the points of intersection of f of x is equal to g of x. F of x equals g of x is, what is f of x equals g of x? F of x equals g of x is basically points of intersection. So we basically want these points of intersection here, 1 and 2. So what was f of x? F of x is 2 cos x minus 30 degrees. What was f of x? 2 cos x minus 30 equals g of x, which is 2 sine x. Now to solve this, we can cancel out the 2 on both sides by dividing by 2. So we left with cos of x minus 30 degrees is equal to sine x. Now in order to solve this problem, we need to use co-ratios. So now where's cos positive? Now when we're using co-ratio, we need to use 90 degrees and 270 degrees. So cos is positive in the fourth quadrant and in the first quadrant. So we're going to write cos. So quadrant 1, we're going to write down cos of x minus 30 degrees. Sin x, we're going to change to cos of 90 minus x. Isn't cos of 90 minus x is sin x? Yes, it is. So now we can drop the cos on both sides. And when you drop it off like this, you need to add the K360 on the other side. Is equal to 90 degrees minus x plus K360. Now we simplify. X plus x is 2x, and 90 plus 30 is 120 plus K360. And now we have x is equal to 60 degrees plus K 180. Right, so that's quadrant 1 solution. Let's just put it here. Remember to write K is an element of Z. Or or we can write cos of x minus 30 degrees is equal to cos of 270 plus x. Now how this here works, cos of 270 plus x, it will change to co-ratio because cos is positive in the fourth quadrant and cos becomes sin x. So that's right. So dropping the cos on both sides like this, cos x minus 30 is equal to 270 plus x plus K360. So x is now equal to 270 plus 30, that's 300. Actually we can't solve this. Yeah, we can't really solve this because if the x and the x cancels out, see the x and the x cancels out, then you're gonna have no solution. So the second one doesn't work out, so not applicable, right? So that's the only answer. Let's check if the points of intersection are at 60 and 180. Should have been at 60 and 180. Okay, so that's my the thing, because 1.73 we put it here, we should have put it here higher up, right? So it should have been here 1.73, and that should have been here exactly on this point here. So we know the points of intersection is at, if I take a value of k which is -1, you'll get 120, -120. -120. So at -90, -120, right? So x is equal to -120 degrees, and the next value of x is at, as we can see here, it is at 60. If I take the value of k as to be 0, I'm going to get 60 degrees. So two answers for x, at 120 and at 60 degrees. We have a point of intersection, right? So you can see this one doesn't work out, so this one is out. Only quadrant 1 solution works out. Next question. Next question we see here, where is g prime x equal to 0? What does g prime x equal to 0 mean? Now this is like from paper 1. When we say this, we looking for minimum and maximum. In other words, we're looking for values of x, min max. So the answer is x equals, when is the g graph, when is it a minimum or a maximum? At x equals, there's two answers here. At x equals minus 90 or x equals 90. Minus 90 and 90. So the answer is, there's two answers here, minus 90 or 90 degrees. I'm writing in set notation, or you can write it like this: x is equal to minus 90 or x is equal to 90 degrees. We have a turning point. Turning point x value only we're looking for. Then where is f of x greater than g of x? Now f of x greater than g of x, I need to look at the graph. Right, so let's copy this graph here. So where is the f graph above the g graph? So I like to do this. We can see the f graph is below here. The f graph is above here. F graph is above the g graph here only. So it's only this place here, from there to there. So from negative 120 less than x, x is greater than negative 120 but less than 60 is between the points of intersection where the f graph, see, f graph is above, g graph is below. So from minus 120, keep on saying minus 60, minus 120 to 60 degrees, this yellow portion here, that's where the f graph is above the g graph. So the answer is from minus 120 to 60. I hope you guys understand. Guys, I made a mistake, and if you go back, when I was solving trigonometry, I was trying to get the value of k here. When I look at the question paper again, remember the value of k is negative. So even though you got this answer over here, see, I said k over 6 should have been, because the value of k is negative, it should be negative k over 6. So the answer for k should be negative 8. So it should be negative 8. Sorry about that, just correct that. Thank you. I hope you understand, because the value of k is negative here. See, should be negative k. Anyways, continuing on to the next question, which is question number 6. That should be, yes, geometry. Now you know you have to give reasons for geometry. And now before we do geometry, we need to read the question and try to understand everything here. So what we know is that SR is a diameter. SR is a diameter, so we know that this angle is 90, angles in a semicircle. If that is 90, this will also make a 90 there. Chord ST is produced to P. ST is produced to P, okay. PR is a tangent. PR is a tangent to the circle, so we're going to get tan chord. So angle R1, alright, is equal to this entire angle here, which is 48, right? So angle R2 will become 90 minus 48. I hope so we can find both these angles here. We know radius is perpendicular to, we know that diameter is perpendicular to a tangent as well, so this whole thing is 90. So many ways to do this problem, right? Chord SV produced meets PR at Q, TV and TR are drawn. Alright, so those are just straight lines. Do we have angles in same segments? Let's see. We should have angles in same segment. Angle R2 must be equal to angle V1. Can you see? ST is a chord, so going towards angle R2 and angle V1. So those are also equal. So let me just put a dot here, because those are equal as well. So I think we have enough information to solve these problems. So let's solve. Question 6.1.1. Write down the size of PRS with reasons. Okay, let's take this up here, right? Let's take this question up here and do it on this diagram. Write down the size of PRS, provide a reason. PRS. PRS. PRS is 90, okay? PRS. So PRS is equal to 90 degrees because diameter is perpendicular to tangent. Let's move on to the next question. Calculate the size of angle P and angle, right? Right, so we want to find the size, calculate the size of angle P. Right, so what is angle P? To find angle P, remember this is 90. So angle R1, so 6.1.2a. What we can say here is angle S, PSR. Okay, let me not use 3-point notation. I don't like to use 3-point notation. So I'm going to say angle S1 plus angle S2 is equal to angle R1, which is equal to 48 degrees. And what's the reason for this? The reason for this is tan chord theorem. Tan chord theorem. Right, so this entire thing is 48. Now because we have 48 and we have 90, we can find angle P. So angle P is equal to 180 minus 90 minus 48. So that's just basically 90 minus 48. What's 90 minus 48? 90 minus 48, that's going to give me 42 degrees. And the reason for this is sum of angles of triangle, sum of angles of triangle PSR. Right, so I gave it with reasons. Now calculating part B, the size of angle V1. That's simple. To calculate the size of angle V1, remember we need to say angle T1. I already marked it here, so we can say angle T1 is equal to 90 degrees. Angles in a semicircle, right? That's 90. Then we can find angle R2. Angle R2 is now equal to 90 minus 48. 90 minus 48, which is equal to 42. We just work that out. That's basically complementary angles, complementary adjacent angles, right? Because that's next to the 90 degree complementary adjacent. So now we can say angle V1 is now equal to angle R2, which is equal to 42 degrees. And the reason is angles in same segments. Angles in same segment. I hope you guys understand this. Don't forget to leave comments if you don't understand. Right, next question. Prove that PQS, last one, prove that PQS equals VTS. PQS, so this angle here, PQS, where's PQS? Let's use another color. PQS, which is angle Q1, is equal to VTS. VTS is equal to this entire angle there. How is PQS equal to VTS? How are they equal? So that should be 90 plus something there, right? So we need to go and figure out what is angle T2. We had, what is angle P1? Let's fill in all these angles here. right? Let's use another color here. So this is 42 degrees. That's also 42. That's also 42 degrees. All right, so we got 42, 42, 42. Yes, how can we solve this? If we make angle T2 equal to x, let angle T2 equal to x, all right? Let angle T2 be equal to x. This implies if angle T2 is equal to x, then we got PQS, not PQS, VTS as 90 plus x. VTS as 90 plus x, right? Okay, that's equal to 90 plus x. Okay, so we have angles in a semicircle, we have a diameter here, alright, and that's angle T2 is x. We should be able to find it, guys, come on. 90 degrees plus x. So what's angle Q1? Can I find angle Q1? Yes, I can find angle Q1 because I got angle V1. What's angle V2? 180 minus 42. So remember, I'm going to use sum of angles of quadrilaterals. So angle T3 should be 90 minus x, because 180 minus 90 minus x. So angle T3 is 90 minus x. Let's write that down. So angle T3 is 90 minus x, alright? Angle T3, I'm trying to solve this. Angle T3 is equal to 90 degrees minus x. Why? Sum of angles on a straight line. Angles on straight line, alright? Angles on straight line. Angle V2 is 180 minus x, angles on straight line. Angle V2 is 180 minus 42, angles on straight line. So you should get 138. 180 minus 42. 180 minus 42, that's going to give me 138. Right, so I have T3 V2. I've got angle P. Now I can find angle Q, sum of angles of quad, right? Because angle Q2 is 138, right? 138. What's 138 plus 42? You can say that this is a cyclic quad, right? Okay, we don't need to prove that it's a cyclic quad. We can just say angle Q1 is equal to minus all these angles. So angle Q1, sum of angles of quadrilateral. Angle Q1, which is the same thing as saying PQS, is equal to 360 minus 138 minus 90 minus x minus 42. Minus 42. Wait, be careful when you're writing 90 minus x. Should be in brackets because that's an entire angle. And minus 42, which is the top angle, which is here. And that was angle P. So what we're writing here is sum of angles of quad. Sum of angles of quad. PQVT. PQVT. Quad. PQVT. And if we work out all this, you can see minus minus x, we're getting plus x. Alright? And if we subtract all these angles, we take 360 minus 138 minus 90 minus 42, we're getting 90. So what we got? We got 90 plus x. So basically PQS equals VTS. This implies VTS. Right, guys, because we did because I didn't know what was angle T2, I just made it x, and that's what you should do. What you should not do is put a value for x, right? Because then if you put a value for x, then you go off. You'll be able to prove it if you put a value for x, but the thing is that's not the way to prove it. You have to use a generalized angle x. I hope you guys understand. Don't forget to leave comments. Right, moving on to the next question. 6.2. Right, so far is like all grade 11 circle geometry, and it's been this paper is like 3 hours, so you really got to think in circle geometry. Anyways, let's see what we have here. In the diagram below, the bigger circle has points E, D, E, O, C, D on its circumference. E, O, C, D. So nice, because these 4 points lie on the circumference, we have a cyclic quad. So we know this angle E, we can find angle C2. How we can find angle C2? 180 minus 42. So that should give us 138, right? Because these are cyclic quad. EOCD is a cyclic quad. O is the center of the circle. O is the center of the smaller circle, right? So since this is the center of the smaller circle, do we have a diameter? No, we don't have a diameter. We just have this part here. We can see line from center is in midpoint of chord. No, we don't know that. That's not. We just have line from center. We don't even know if it's midpoint or what. C is the point of intersection between the two circles. Okay, C is the points of intersection of the two circles. Okay, A and F are two more points on the circumference of the smaller circle. A and F. Okay. Because we have center here, we can say angular center equals twice angular circumference. But how? Okay, there's angular center. Angular center equals twice angular circumference. So there's it here. That's the reason why they told us that's the center of the circle. So if that is 66, 66, you should get what's 66 times 2? 66 times 2 should get 132. Now because that's 132, you can find angle D. 180 minus 132. 180 minus the answer 48. So this is 48. And what other information can we take from here? Alright, that's it. We want to prove that AB is equal to BC. In other words, we want to prove that this angle is 90. Yes, if that angle is 90, then we have line from center perpendicular to chord, and is it 90? See, 42 plus 48 is 90, and that becomes 90. So perfect, it's proved already just by using all this information. So how did we start? We said angle D, we said opposite angles. All right, first we said opposite angles of cyclic quad, right? Opposite angles of, so angle C2 is equal to 180 minus, that's how you're going to start off your proof, right? Because you're proving that 180 minus 42, so that's 138 degrees. The reason for this is opposite angles of cyclic quad. Opposite angle of which cyclic quad? EOCD, right? Right, so that's how we got 138. How did you get 132? Angular center equals twice angular circumference. Angle O1 is equal to 132. Angle at center equals 2 times angle at circumference, right? And that's done. And then we said angle D is 48. Angle D is equal to 180 minus, we don't have to say 180 minus 132. You can see it's opposite angles of cyclic quad as well, O1 and D. Angle D is 48. Opposite angles of cyclic quad, same cyclic quad, EOCD. Now when you say sum of angles of triangles, and please label the triangle, label the cyclic quad EOCD, like what I'm doing, right? And now we can say in triangle BCD, so now we can say angle B is equal to 90 degrees. Why? Because we said 180 minus 48 minus 42, that is sum of angles of triangle EBD, right? Now that gives us line from center perpendicular to chord. So this implies AB is equal to BC. Why? Because line from center perpendicular to chord, and we know because OB is perpendicular, so this therefore you can say OB is perpendicular to AC, and that's how you should be able to prove this. I hope you guys understand this. Let's move on to the next question. Question 7. We're almost there, guys. All right, just hold on. Right, so we want to prove this tan chord theorem, right? So we want to prove that VST is equal to angle R. VST is equal to angle R. So what you should do is construct a line, construct diameter, call it K here, right? And then join KR. Let's redraw this line here. Join KR. So you should write construct diameter, SOK. Was there P? Let's call it SOP. SOP, and then join PR. Right, so we did this. Now we can write, call it R1 and R2. Now your proof come here. So you can say angle R1 plus angle R2 is equal to 90 degrees because we have angles in a semicircle. Angle R1 plus angle R2 is equal to 90 degrees. You know what? Let's call angle R, let angle R1 be equal to X as well. Be easier. Let angle R1 be equal to X. So I'm calling that X. And we can say angle R1 plus angle R2 is now equal to 90 because we have angles in a semicircle. How? Because that's the diameter. So we got angle R2, which is equal to, what's angle R2? Angle R2 will now be equal to 90 degrees minus X. Right, so that's 90 minus X. Perfect. Now, same story here. Actually, we should be working on this side. Look at the tangent. We have a tangent here. Trying to draw 90 degrees here, right? So remember, the idea is to get this here to be equal to X. So we have a tangent, call it S1. Let's call it S1 and S2. So we want to get angle S1 to be equal to X. We are supposed to get angles in the same. Okay, this is 90. So we can say angle S1 plus angle S2 is equal to 90 degrees because we have diameter perpendicular to tangent. Alright, so now how do we solve this? Okay. that's x. We should have made that top angle equal to x rather. Then we could have got 90 and 90 minus x here. No, let angle P equal to x. We're just going to correct this. So because we suppose to be using angles in same segments as well. So you see, let angle P be equal to x rather. Right, so there's no reason to write this out. So we know that's 90, 90. And yeah, we're not going to say that this is x, right? We're going to say that angle there is x. So now we have angles in same segment, which makes angle T be equal to x. So what we can say is now angle T is now equal to angle P, which is equal to x. Angles in same segments. Now how will this help us? Because we have x here, we have x there, we got an angle which is 90 minus x there. That's going to be x. That's x here. Did we prove it the other way around? We proved that angle VST is equal to angle R. I think we're supposed to join PT rather. Supposed to join angle PT rather. Rather this. Okay, we tried putting the x there, let's try putting the x here now. Sorry guys, well, it's bookwork, so you should be able to figure it out. I'm just doing this like after a really long time, but anyways, shouldn't be difficult. Let's make angle R2 be equal to x. If angle R2 is x, right, then we got, let's bring this down. We won't say this now. What we have here is 90 and 90, that's fine, right? We will have angles in same segment. See, if you look at arc TP or chord TP, is going towards x there and towards x there. That's what we wanted. We wanted an x here. So let's call this angle S1, S2. So now we have an x here. So we're going to say angle R2, angle S2, angle S2 is equal to angle R2, right? So angle S2 is equal to angle R2 is equal to x, because angles in the same segment. We know that is 90. So what we can say is angle S1 is equal to 90 degrees minus x, because we said diameter perpendicular. So this implies angle S1 is 90 minus x, which is also the same as saying VST. And what is angle R1? That's also 90 minus x. So from here you could have said angle R1 here. Let's move this down. We could have said here, the whole purpose of writing that other part was to say angle R1. So we can find angle R1, which is equal to 90 minus x, because angle R2 is x. Angle R2 is x. So make sure guys, when you trying to solve this, place the x in the right angle. Make sure the x is at the correct angle. So now we learnt it, right? So so we got angle S1 as 90 minus x, and we got angle R1 as 90 minus x, and this angle R1 is basically equal to angle R in general, right? So this implies angle VST is equal to angle R. That's basically without construction. You shouldn't say angle R, use 3-point notation. TRS. VST equals TRS. TRS. Right, I hope you guys understand. Let's move on to the next question. We wasted a lot of time on that. Right, 7.2. Now write with the reason 3 other angles each equal to x with reasons, right? So a famous question. So far all these questions were like grade 11 problems, right? Nothing exciting here. No similar triangles, no, so far. So what we have is another circle geometry problem. LG is a tangent, right? Because it's a tangent, we can use tan chord here. Angle P will be x. See there? Tangent. So directly opposite the chord is angle P, which is x, tan chord. Oh, we have a nice this thing here. See, equal chords subtend equal angles. Equal chord subtending equal angles. So angle G1 will be equal to angle G3. But anyways, since it's a tangent, remember this is 90. So this angle will become 90 degrees minus x. So if this is 90 minus x, this is x, then this here will become 90. And equal chords subtending equal angles, so this is also 90 minus x on top here. Angle G1. Anyways, chord HF cuts the chord GP and EG is parallel to PL. Now we have to use the parallel lines to get somewhere. EG, so we got angle P to be x, so angle G2 will also be equal to x because parallel lines. Where else was x? X was here. Now we got an x there. Will this help us to get an x there? So I've got one x, I've got another x here. Where's the third x? We got a 90 here, we got an x there, that's 90 minus x. Because of this triangle here, that's 90 x, 90 minus x there. If that is 90 minus x, I can take a corresponding there, that's 90 minus x. There's another angle which is 90, which can we take a perpendicular somewhere? That's alternate angles. So okay, let's write down what we have so far and not lose that information. So first we're gonna write angle P is equal to angle, that's the first one, angle P is equal to angle G4, which is equal to x. Tan chord theorem. Then we said we took an alternate, taking an alternate, which is angle G2 is equal to x. Alternate angles. Why is it alternate? Because EG is parallel to PL. Now the third one, we are just stuck with the third one. We said equal chords subtend equal angles, right? Do we have a cyclic chord here? Tangent EFGHP. EFGHP. Chord PH is produced to L. Chord PH is produced to L. That's fine. Chord HF cuts the chord GP. Chord HF. Chord HF cuts the chord. Okay, let's try angles in same segments. There's it here. Angles in same segment. Look at GH. We're going towards angle P, and look at GH. that's going towards angle F. So we found angles in same segment. So that is also X there. So angle F2 is equal to angle P is equal to X. That's angles in same segments. Perfect, guys. Excellent. Right, let's move on to the next question. Three other angles each equal to X. So there's the three angles. Next problem. Here's it now. Now we go on to grade 12, where we have to prove similarity. Right, now how do we prove similarity here? In triangle HMG, so let's write that order down first. In triangle HMG and triangle EFG, right? HMG and EFG. What's the first one? Let's see what we are working with here first. Right, 1 second. Let's take all this down. Because I need the diagram with that information. So let's take all this down. Right. Let's take all this information down. Right. And I need the circle. So let me cut this out. I need it with this information, so I know what I'm working with here, so you don't get confused. So just follow through and learn. Right, let's see. Let's move this. Right, so let's see what we are working with here now. HMG. So we have, I'm just going to shade it in, HMG, HMG. So we're basically working with, let's use a different color. Let's use HMG is this, HMG, and we are working with the next triangle, which is HMG and EFG. EFG. EFG 2. So obviously that makes sense now, because now we want angle H2 and we need to have three angles. Okay, HMG and EFG. So what we can see is that we have equal chords subtending equal angles, so we can say angle G1 is equal to angle G3, which is equal to, why did we say it's 90 minus x? Okay, we can say that later, we don't need it here now. We can say equal chords subtend equal angles. Equal chords subtend equal angles. So that gives us angle G3 and gives us angle G1. That gives us G3 and G1. Equal chords subtend equal angles. What's the second one? We are supposed to get M3 to be equal to angle F somehow, or angle H2 to get angle H2 to be equal to angle E. Either way, that's 90 minus x, that's 90, that is x. If we try this again, use chord GH, we're going towards angle F2. If I make angle F2, if I make angle F1 equal to y, then I will have x plus y. If I make this equal to y, then I'm going to have x plus y. Then we can get angle M3 as x plus y. But how? Okay, x plus y. if I make this here equal to y, alright, okay guys, I just figured something out here. See, if I add, alright, so this was the second diagram I was working. See, if I add this x and the 90 minus x here, we see that this part is, this angle here becomes 90, angle G1, G2 becomes 90. See, if I add the 90 minus x and the x, but how did we get 90 minus x over here? That's a problem. Right, so how did we get 90 minus x over here is because so if I get this to be 90 minus, if I can get this to be 90 degrees, that's x, then h2 will become 90 minus x. h2 will become 90 minus x. How will that help me? If I make this 90, no, but that can't be 90 because we already have a 90 on this side. Why did I put a 90 minus x there? Why did I put a 90 minus x there? Okay, I'm going to retake this diagram. Let's take this out. Why did I put a 90 minus x here? We got a 90 minus x here because that's 90. Why is this here 90? Take this out. Did they say M is the center? No, M wasn't the center. No, if this is 90, wait a minute. So if this is x, that's 90 minus x, x 90 minus x, then h1, h2 will become 90. Then this here becomes the diameter. If this here becomes the diameter of the circle, converse angles in same segment. Right, we have to figure this out. So we got h1, h2. That becomes the diameter. I'm trying to get, okay, let's take this 90 minus x out here. Okay, I need a clean diagram because this is getting a bit too messy. Let's go back here to our diagram. We have to retake everything again and think about what to do. It's 5 marks, so we have to think about what we need to do. So we know G3, G4 is 90. So this angle is 90 degrees minus x. We don't really need that now. No, actually we do need it. So we should change this. Let's change this a bit. So we are going to say equal chords subtend equal angles. Just below, let me just rearrange this. Equal chords subtending equal angles. Alright. But now this here is equal to 90 minus x. We're going to put it as 90 minus x. And the reason for that is still part of the first proof. So we know this is a tangent. Is GL a tangent? We need to read here. LG is a tangent to the circle. Oh, but why are we putting a 90? There's no 90 there. Okay, that's where the problem is. There shouldn't be a 90 there because we don't know that that is a diameter. Alright, so my mistake. There's no 90 there. Okay, so there's no 90 there, right? Because we don't know that this is the diameter. So be careful. So we know that that is a tangent. So this is the information we have so far. So I'm going to take out this. We can't really say this as well. So back here. Right, so it's important that to figure out the problem as well. Right, so that's x. We said this was x as well. tan chord, then we took alternate, that was x. And what was the third one? We said angles in same segment, going here and going E2, that was also x over here. That's the only information we have here, and we don't have any 90s and stuff. Alternate angles x, x, and x. We just have the three x's. We can say angle G1 is equal to angle G3 because of equal chord subtending equal angles. What else, guys? What else? Parallel lines. Can we take a parallel here? Let's take a parallel here, go up, and go up here. Will that be a parallel line as well? What else? What else? We have x, x. Guys, we could have also said G4 is equal to F2 because of tan chord. There's tan chord here and there's tan chord there in two triangles. Okay, I'm gonna try and look for angles in I'm gonna look for FG. There, I found it. Yeah, so see, look at line FG. So angle E is equal to angle H2. Shoo. Why wasn't I looking at this? Alright, so there's it here. Angle E is equal to angle H2. Angle E is equal to angle H2. Now we're flowing because we solved the problem. Angle E is equal to angle H2 because of angles in same segments. We have another angles in same segments. Right, perfect. And then we got G1, and then we got angle F1 plus angle F2. The third one is just remaining angles, or angle EFG is now equal to angle GMH or HMG. Right, 3-point notation, you can use that, and we can say sum of angles of triangles. Right, so perfect. Sure, I can't believe I put 90 there. Sorry guys, but I hope you understand why it's not 90, because that's not a diameter. Okay, so EFG, so triangle HMG is now similar to triangle EFG because we have angle, angle, angle. We have three angles that are equal, and that proves this entire thing. So we know this triangle is similar to this triangle over here. Right, so those are similar triangles. Nice. So let me just mark this as well. That's part 1, part 2. 1 is similar to 2. Now let's look at our next problem. Hence or otherwise prove. Because they said hence or otherwise prove PH times HG. Right, so hence or otherwise prove. Right, so we're going to take this information here, right, and put it here because that's going to be our reason for. So what do we want? We want PHHG. We want PHHG. PH times HG. PHHG. One second, we want PHHG. PH times HG. 3 and x. Okay, so these are the sides that they want. Let me retake this triangle, this circle problem again. Let's see what they want here. Because we can get like really lost here. they want EG. These are all the sides that we're going to mark off. PH, right? HG, but we know PH is equal to EF, so we're going to take EF. EG, HM. HM is fine, and EG is also fine, right? So we're going to use EG and HM. So we can say EG over EF. Right, so this is going to be your reason. EG over EF. EG over EF equals HG over HM. Now remember what we need to keep. We need to keep EG and HM. So we can cross multiply these two out. So now we're going to cross multiply them. And what's your reason for that? Your reason for that is similar triangles, right? So that's your reason for that. Let's take all this out here, right? So your reason is this, or sometimes just write similar triangles. You can just write this as a reason. Anyways, continuing here, EG, HM, we need it on that side. EG times HM, and on this side we need HEF times HG. Now we need to keep HG, EG, HM. We need to replace EF, but we know that EF is equal to PH, but EF is equal to PH, which is given. So first you tick off all the sides and then you see the relationship, right? So that's given. So PH, this implies we have PH HG is equal to EG times HM. Sorry about this, guys. Took us like really long because we were assuming stuff here incorrectly, right? But I hope you understood the entire problem, like how we worked through it. We didn't even need the 90s anyway. Moving on to the next problem and the final problem, which is question 8. What we have is nice parallel lines within a triangle, which is prop theorem, proportionality theorem, this grade 12 stuff. Right, so in the diagram below, triangle ABC is drawn with D on BC, and I think everything is given here with the parallel lines. AC is 6,5. That's not, that information not given. AC is 6,5 and BC is 6. Alright, so BC is 6, AC is 6,5. Determine the length of AB. Now before we do anything, we need to write down all the triangles that has prop theorem in it. So what are the prop theorem triangles? So first we have triangle BCE, triangle BCE, right? Do we have another triangle here? We have triangle B, we said BCE. Why is it triangle BCE? Because we got FD parallel to EB, and the big triangle BCA or ABC, and we have triangle ABC. These are the two prop theorem triangles that has a parallel line in it. Now solving this problem, determine the length of AB. They said AC is the entire distance AC is 6,5 and the entire distance BC is 6. So to find AB, we can just use Pythagoras, right? AB is equal to square root of 6,5 squared minus, because AC is a hypotenuse, minus 6 squared, and that is Pythagoras theorem, right? So write down Pythagoras. Right, so since it's Pythagoras, so let's see what answer we get. So we're going to say square root 6.5 squared minus 6 squared. I'm getting 5 over 2. Right? So AB is 5 over 2. Perfect. Next question. So I need this information over here. See, 5 over 2 or 6, 2.5. Right, so I need this information here to solve the next problem probably. Prove that CB equals and it's 6 marks. Prove that BC equals square root prove that BC equals square root of AC times CE. AC and CE. AC and CE. Okay, so we are working with AC. AC is 6.5. BC. What is CE? Okay, that's what we got to determine. We got to go and determine CE. So let CE be equal to X. Let CE be equal to X, then AE now becomes 6,5 minus X. X, and this is 6,5 minus X. And do we need EB? Yeah, now we can find EB because this is 6,5. Then we can determine EB. This implies EB is now equal to the EB squared. Use Pythagoras because we are looking at this small triangle here. In triangle, look at this triangle because we got 6,5 minus X here. 6.5 minus X. And this is X. Let me write this in red. Right? So we can find EB. Once we find EB, what do we do? Then BC unless we think about similar triangles here. Yeah, unless we think about similar triangles. Okay, let me try this method out first and then try similar triangles, okay? Because I can say this is CB squared, then I got ACB. No, let's try similar triangles. Yeah, that will work out much better. Okay, what if I do try this? Sorry about that. Let's go back and okay, let's work with our idea here. What is EB? So in triangle ABE, I got EB squared is equal to 5 over 2,5 squared minus 6,5 minus X all squared. That's what EB squared is. That's EB squared. EB squared. I've got 6 here, and I can also write EB in terms of this triangle over here, which is BCE. In triangle BCE, I can say in triangle BCE, what I can say here is, in triangle BCE, I can say that EB squared is equal to, which becomes the hypotenuse, 6 squared minus x squared. So I think we should be equating these two and find the value of x. This implies 2.5 squared minus 6.5 minus x all squared is equal to 36 minus x squared. But what happens here is that x squared and the x, no, we're going to go in circles, right? So obviously this method doesn't work, so you can't really try this out. We should try prop theorem out, right? We should try prop theorem, but how? Or should we try similar triangles? Let's try similar triangles. I think similar triangles should work. Let me try similar triangles. So how are we going to work with similar triangles here is that what we're going to say is square both sides. So we're going to say CB squared is equal to AC times CE, EC, AC times EC, or same thing, squaring both sides. So we can say break up CB times CB equals AC times CE, right? So we can say CB over AC. So do we have ABC? ABC. Yeah, so we got triangle ABC and CEB. CBE. Yeah. So we're going to take CB and CB divided by AC, and so again similar triangle. So my idea was there, but I was just trying that method out. So triangle ABC, because when I tried that squaring method, both the x squared cancels out, so I'm not going to get anywhere. Triangle ABC and triangle ABC and triangle, what we said, ABC and triangle BEC. BEC, yes. So we're going to have three reasons, right? First one, so I can take this out now because that's just my ideas. Let's put it in a block and throw it away one side. Right, so what we can say is angle C is common. Number two, we can say BEC is equal to ABC is equal to 90 degrees. That's given. And the third one is what we can say is angle ABC, not ABC, angle EBC. Angle EBC is now equal to angle CAB or BAC. That's the remaining angles or sum of angles of triangles. So what we have, this implies triangle ABC is now similar to triangle BEC, and that's angle, angle, angle. Therefore, we got CB over AC, CB over AC. Remember, CB over AC is now equal to what we said, CB. So CE over BC. Now if we cross multiply, we have BC times BC. In other words, we have CB squared equals, this is from similar triangles. We have BC squared equals, cross multiply, ACCE. Right? AC times CE. Or CA times CE. So this implies BC is now equal to the square root of CA times CE. Sure. I hope you guys understand. Yeah, so these kinds of problems can be really tricky. So just be careful, guys. And I hope you are enjoying the video so far. It's been a really long paper. That's why it's 3 hours. Okay, so far so good. We proved that using similar triangles. I thought it would have been prop theorem, but anyways, continuing. They said hence determine the length of CE correct to 1 decimal place. So BC is right. So I think we need this diagram here again. Okay, so we know what BC is. We want to find CE. So because they said hence, use the answer above. So we know BC is equal to the square root of CA times CE. What is BC? BC is 6 and AC is 6,5 times CE. Right, we're going to square both sides, so we're going to get 36 is equal to 6,5 times CE. So CE is now equal to 36 divided by 6.5. 36 divided by 6.5. I got 72 over 13. So CE is now equal to, let's say correct to 1 decimal place. So 5,5 units. Correct to 1 decimal place. What was that? Centimeters, meters, what was it? Units. I hope you guys are understanding. Write down the length of AE now. So remember we got, copy this. Now remember we got CE, which is, let's use a different color. We got 5,5 here. CE is 5,5. So obviously AE will be 1. So length of AE is equal to 6,5 minus 5,5, which is equal to 1 units approximately. 1 unit. Not units. 1 unit. Next problem. Determine the length of EF. 5 marks. Determine the length of EF. Let's just do it here whilst we have all that information. How can we find EF? Should we make this X? We can find EB. So we can find EB, which is using Pythagoras, because remember that angle is 90. So EB is equal to 2.5 squared minus 1 squared. Let's see what's that. 2.5 squared minus 1 squared. That's going to give me 2.29. Let's just use root 21 over 2. Nah, I think we can just use 2.29. 2.29. 2.29. Alright, so that's because of Pythagoras. That is EB is 2.29. Let's use a different color here. That's EB. We want to find EF. So there I found like another 90 degree here because of corresponding angle. We know that is 90 because this here is 90, that's 90. This triangle is complete, right? So can't I use prop theorem for this? Can we use prop theorem? Whoa, this is incorrect. Can't say this because AE was no, that is right. We said AE is 1 unit. AE is 1 unit, that's 2.29. It's 5 marks, so we're almost there. What's BD? Let's try to use prop theorem. So if we say CF over FE, CF, do we have CF? No, we don't have CF. Okay, we can say CE over FE. We're saying CE over FE. We're trying to use this triangle here. CE over FE is equal to CB over BD. Prop theorem, because FD is parallel to EB. FD is parallel to EB. So now we have FE over here, and we can fill in all these information. CE. What was CE? CE was 5.5, right? CE was 5,5. FE is what we need to solve for. BC. Where's BC? BC is 6, and BD is unknown again. BD is down here, BD. So we can say this implies FE times 6, FE times 6 equals 5,5 BD. So now we need to find BD. Alright, to find BD we need to use the big triangle now. So let's try to use the big triangle. So what we can say is same CE over AE, CE over AE equals CD over BD. Now we can find, because we got CE over AE, we do have that. And then we can find CD over BD, then we can get BD. If we get BD, then we can solve this problem. This is also prop theorem, because ED is parallel to AB, right? So CE over AE, what is CE? 5.5 over AE, which is 1. CE over AE, 5.5 over 1 is equal to CD actually we don't have CD, so this is incorrect. Shouldn't say that. We should say the whole thing. AC over AE, should say the whole thing. AC over AE, AC over AE equals BC over BD. Yeah, AC over AE, AC over AE equals BC over BD. Yes, that should be fine, because then we can find that proportion ratio. AC is 6,5, AE is 1, BC is 6, and BD is unknown. This implies 6.5 BD is equal 6.5 times BD equals 6. So BD is equal to 6 divided by 6.5. And 6 divided by 6.5, 6 divided by 6.5, we're getting 12 over 13. Let's just write it as 12 over 13 for now. Right? That's BD. And remember what we said BD was. This implies FE is equal to 5.5 times BD over 6. So what we have here is 5,5 times, what's BD? 12 over 13 divided by 6, and we can work that answer out. 5.5, and we're done almost, guys. 5.5 times 12 over 13, and we're dividing it by 6, and we got an answer of 11 over 13. I hope you guys understand. Sorry about this, it just took like really long, right? And yes guys, this brings us to the end of our June mathematics paper 2, the KZN paper. Don't forget to subscribe to my YouTube channel, and all the best guys. Thank you.